The universe is a system that encompasses everything you see when you look around, gaze at space, or explore it with any tools, leaving you amazed at its wonders. Although its exact origin is still unknown, it is estimated to be around 13.8 billion years old. So, what are the size, history, and mysteries of the observable universe? In today's video, we aim to answer these questions and deepen our curiosity about the cosmos. Don't forget to like our videos and subscribe to our channel to support its growth. First of all, as humanity, we currently cannot observe the entire universe we exist in. Due to technological limitations, it is highly likely that we can only see a very small portion of it. Additionally, there may be unknown universes beyond our own, and these universes could host entirely different forms of life. The age of the universe can be calculated through light. Scientists measure the distance traveled by light to reach us, and the distance corresponds to the age of that light. The oldest light that has reached us from the universe is 13.82 billion light-years old. When it comes to determining the size of the universe, we cannot reach a definitive conclusion. This is because there are potentially many dimensions. Everything has its own dimensionality, such as 2D or 3D. Unfortunately, the universe has not provided us with the slightest clue about how many dimensions it has so far. If the universe is three-dimensional, it could either be infinite in size or far larger than our estimates. Now, let's take a look at the early stages of our universe. First proposed by Alan Guth, the cosmic inflation theory suggests that the universe began expanding and growing at an extremely rapid rate, starting from 10 seconds after the Big Bang. This means that the universe expanded within a time frame that was just a fraction of a second, 1/10 quadrillionth of 1 quadrillionth of 1 quadrillionth of a second after the Big Bang. Prior to this, it was expanding at the speed of light. Using this information, scientists conducted a series of calculations and estimated that the actual size of the universe is approximately 300 trillion times larger than the observable universe. This translates to the universe being about 263 quadrillion kilometers in size, which is approximately 263 quadrillion kilometers. And this is the minimum estimate. In short, the calculable universe is extraordinarily vast, and this refers only to the calculable part. The universe could, in fact, be infinite. As the universe is thought to expand every year, it may continue to grow infinitely unless it encounters an event, such as a collapse or explosion, that brings about its end. Speaking of the end of the universe, how do you think it might happen? Based on our research and thoughts, we will share our interpretation of this question. Currently, it is widely accepted by scientists around the world that our universe, created 13.8 billion years ago during the Big Bang, originated from an extremely dense and hot point. When we hear the word explosion, most people imagine a chaotic event with lights and debris flying everywhere. However, you shouldn't think of the Big Bang this way. When the Big Bang occurred, as the universe was forming, it wasn't a fiery explosion, but rather the sudden emergence of a three-dimensional space and spacetime, followed by the expansion of this space. During the initial moments of the universe's formation, what we call the explosion and expansion, an immense amount of energy flooded the cosmos, filling it with radiation and plasma for about 400,000 years. After this 400,000-year period, the universe began to cool down. This cooling allowed the formation of the first neutral hydrogen atoms, as well as the combination of leptons and quarks, marking the beginning of structure in the universe. These hydrogen atoms, together with leptons and quarks, made it possible for light to travel freely through the cosmos. As a result, the hydrogen clusters began slowly transforming into stars. The stars that formed eventually reached the end of their lifespans, leading to massive explosions. These explosions, in turn, gave rise to nebulous regions that would go on to birth new stars and planets. Through this continuous cycle, roughly 14 billion years later, the universe we see today, including the one we live in, came into existence. As generally accepted by people around the world, it is believed that our universe will eventually come to an end. This end is not thought of in terms of distance, but rather lifespan essentially, the idea that our universe will also have a death. But why does humanity as a whole think such a thing will happen? The fundamental reason for this belief lies in the fact that everything in the world and the cosmos moves from order to disorder. This phenomenon is called entropy, and I can summarize it for you like this: the birth, growth, and death of a living being, the production, rusting, and eventual crumbling of a piece of iron, and finally, the birth, maturation, and inevitable destruction of every planet and star we see in our vast universe. In short, as a general principle, everything in the universe starts from zero and eventually returns to zero. This is why people believe that just as the universe had a birth, it will also have an end. Although we do not have concrete data or definitive information about how this end will come about, there are, of course, many theories regarding this subject, just as there are countless other mysteries of space and the universe. Before we delve into the end of our universe, I want to talk to you about dark energy and dark matter, as these two concepts form the foundation of many of the theories we will discuss shortly. Dark matter cannot be observed or studied directly, which is why we have very limited information about it. However, we do know of its existence. But how is this possible? The answer lies in the gravitational forces exerted on planets and everything else in space. According to the general theory of relativity, proposed and published by Albert Einstein in 1915, we know that light is affected by the gravitational force of matter present in space and time, such as stars and planets. By observing how light is influenced by this gravitational force, we can infer the existence of matter in space. Scientists noticed that light would sometimes arrive distorted, as if it were influenced by a gravitational force, even though there appeared to be nothing around it. When they examined the area surrounding the light, they found no visible structure or object. These observations led to the discovery of dark matter, something that cannot be directly observed, but is undeniably present. Dark energy, on the other hand, is even more mysterious than dark matter, and we know significantly less about it. While dark matter is thought to exert a gravitational force, dark energy is believed to do the exact opposite. It has been driving the rapid expansion of the universe ever since the Big Bang, and this expansion shows no signs of slowing down. In essence, the existence of dark energy is still a mystery. You can think of it as the name we've given to the force that appears to be expanding the universe, simply because we don't yet understand what it is. If, in the future, the source of this expansion or the mechanism behind it is discovered, dark energy will likely be replaced by that newfound explanation. Now that we've discussed dark energy and dark matter, we can move on to the theories about the ultimate fate of our massive universe. The first theory is known as the heat death or the Big Freeze. According to this theory, all stars, planets, moons, and even every structure in the universe will eventually reach the same temperature. As a result of this uniform temperature, there will be no energy transfer between matter. Without energy flow, the entire universe will appear dead, leading to its end. Essentially, the universe will freeze. While this theory may sound implausible to many, it is considered one of the most likely scenarios. This is because we are already in a process similar to what the theory describes. Trillions of years from now, as the universe continues to expand, it will have stretched so much that galaxies like our Milky Way will merge with others. These mergers will result in a future where distant galaxies will no longer be visible from our galaxy. About 100 trillion years from now, the formation of stars, which has been ongoing since the birth of the universe, will come to an end, marking the conclusion of the stelliferous era, the era of stars. Following this era, the degenerate era will begin, during which all galaxies will have disintegrated, star remnants will be scattered across the universe, and all matter will eventually be trapped within black holes. Black holes are expected to be the final remnants of matter before the universe's ultimate demise. They can be thought of as the last soldiers in a fortress holding out during a war. Even black holes, which can endure for an incredibly long time, will eventually vanish. As Stephen Hawking explained, black holes slowly emit their particles into the universe, a process known as Hawking radiation, which will ultimately lead to their disappearance. After the black holes are gone, the universe will enter what is considered the longest and final era of this theory, the dark era. In this dark era, no matter will exist. Over trillions of years, the universe will gradually cool down to such an extent that there will be no energy flow or heat. Consequently, no new forms of life or matter will arise. As the universe continues to cool, it will eventually freeze and cease to exist. This is one of the most compelling and logical theories about the fate of the universe, among the many that have been proposed. The next theory is the Big Crunch theory. As you know, the universe has been expanding rapidly since its inception. According to this scenario, after trillions of years of expansion, the universe filled with an unimaginable amount of matter will no longer be able to withstand the gravitational pull of all this matter. It will collapse inward at an incredible speed. However, in this theory, the universe doesn't have a definitive end. This is because the collapsing universe would return to the initial state it was in at the moment of the Big Bang, a singular point. This singularity could be triggered again, causing another Big Bang and leading to the formation of a brand new universe, much like our own. If no such trigger occurs, the universe would remain as a singularity indefinitely. Additionally, if this theory were to be correct instead of the previous one, it would suggest that many other universes, vastly different from ours, could already exist. While this theory might seem more plausible and logical to some compared to the Big Freeze theory, it is actually quite unlikely. This is because our universe consists of only about 4 to 5% visible matter, 24 to 27% dark matter, and a significant 68 to 72% dark energy. The gravitational pull exerted by visible matter and dark matter is not strong enough to cause such a collapse. For the Big Crunch to happen, dark energy, which currently drives the expansion of the universe, would need to have a gravitational pull as of accelerating the universe's expansion. If that were the case, this theory could be valid. However, even in such a scenario, dark energy would have to emerge trillions of years after the formation of the universe. If it had appeared shortly after the Big Bang, the universe would not have existed until today. Instead, it would have collapsed shortly after the appearance of dark energy. If dark energy were to develop today, or billions of years from now, and possess gravitational properties, the Big Crunch theory could become a reality. In short, for the Big Crunch to occur, the expansion rate of the universe would first need to slow down, and then the next phase of collapse would begin. However, this is not happening. On the contrary, the universe continues to expand at the same rapid pace. Therefore, this theory is, unfortunately, considered one of the least plausible and least likely among all the theories about the universe's ultimate fate. So, at this point, the last theory seems both impossible and highly unrealistic. However, we can never definitively say what might happen in the universe. A single matter or event emerging out of nowhere could lead to the collapse and destruction of our entire universe. There are thousands of theories about the end of the universe and our world. While some of these are truly based on science and mathematics, many are illogical and inconsistent with scientific principles. That said, no matter how unscientific a theory may seem, the universe is such a strange place that what we deem impossible could, in fact, happen. So, do you have your own theory or idea about the end of the universe? If so, don't forget to share your thoughts and theories in the comments. We are always committed to continuing our scientific research and striving to explain these fascinating topics in detail to you, our science-loving audience. To help our channel grow and gain more visibility, don't forget to subscribe and like our videos. Also, as you know, we enrich our content with your ideas and comments. So, make sure to share your thoughts in the comments below. stay safe, and we'll see you in our next video.